안녕하십니까. 저는 울산과학대학교 반도체학과 16학번 엄창민입니다. 제가 홍보할 반도체 회사는 어플라이드 머티리얼즈라는 회사입니다. 북차에는 반도체란, 어플라이드 머티리얼즈 소개, 그리고 어플라이드 벤처, 어플라이드 머티리얼즈의 제품 및 기술 순으로 소개를 드리겠습니다. 반도체란 전기 전도도에 따른 물질의 분류 가운데 하나로 도체와 부도체의 중간 영역에 속한다. 순수한 상태에서는 부도체와 비슷하지만 불순물의 첨가나 기타 조작에 의해 전기 전도도가 늘어나기도 하는 것이다. 어플라이드 머티리얼은 전자제품, 반도체, 칩 제조를 가능하게 하는 장비 서비스 및 소프트웨어를 공급하는 미국 법인, 컴퓨터, 스마트폰, 텔레비전, 태양광 제품에 대한 평판 디스플레이. 이 회사는 또한 유연한 제품 포장 및 기타 응용 프로그램을 위한 코팅을 생산하는 장비를 공급한다. 이러한 것들을 바탕으로 총 매출 약 11조 5천억, R&D 투자 약 1조 8천억 원, 1200개 이상의 특허 보유를 하고 있고 전세계 18개국 81개 지사 14,000여 명이 근무하고 있다. 어플라이드 벤처란, 어플라이드 벤처의 투자는 고성장과 고수익 가능성이 높은 초기 단계의 기술 기업을 중심으로 이루어집니다. 어플라이드 벤처 설립의 목적은 어플라이드 머티리얼즈의 전문성을 보완하거나 증진시킬 수 있는 기술 가능성을 보유한 기업을 발굴하여 수익성 높은 투자 활동을 하는 데 있습니다. 제가 소개드릴 어플라이드 머티리얼즈의 제품은 반도체, 태양광, 디스플레이, 로투롤 웹코팅입니다. 우선 반도체입니다. 지금부터 보여줄 동영상은 실렉트라 엣지 시스템이라는 것입니다.
When etching with Selectra, we're able to recess the tungsten and titanium nitride at the same rate at the top and the bottom of the structure. This gives us a very uniform etch that enables device manufacturers to tune the process to enable maximum contact size and hence minimum resistance. In this example of a traditional etch process, we see that there's a faster etch rate at the top of the structure. This is because for high aspect ratio structures, the chemical refresh is much slower at the bottom of the device. This will become more of an issue in future nodes when the structures become deeper and the thickness of the layers becomes smaller. With the Selectra system, we can widen the bottom doped oxide without damaging the TiOS or nitride layers above. That allows us to improve the metal deposition in the next step and drive device performance without increasing the CD. We can control the etch amount to tune whatever shape the customer would like to form and can even account for incoming etch variation to enable smoother integration. In order to scale DRAM devices, we need to be able to widen the bottom of the capacitor structure without damaging the silicon nitride that defines the critical dimension at the top. With a traditional wet etch process, we can see that the entire stack is widened. The CD is much wider, and the lack of selectivity to TiOS oxide can cause leakage pathways that degrade the memory retention time. The Selectra etch process is not crystal dependent, and we can completely remove silicon without having any residues. Selectra is also extremely selective to dielectric material. It etches silicon 2,000 times faster than oxide or nitride, which allows us to remove all of the silicon without damaging the dielectric material. The key challenge for this application is to completely remove silicon from the dummy gate. Traditionally, this process has been completed with a wet chemical etch, but silicon wet etch is crystal dependent, and there will always be some silicon residues in the corners that cannot be etched. Another key challenge is high selectivity to dielectrics. We want to completely remove the silicon without damaging the nitride spacer or the gate oxide underneath. In this animation, you can see that the traditional wet etch does remove the bulk silicon of the dummy gate, but once the etch gets down to the bottom of the gate, you can see that the silicon is not completely removed. Customers have had to live with this issue in the past nodes, but at 10 nanometers, the size of the dummy gate has gotten so small that the electrical impact can no longer be tolerated. In the Selectra chamber, we're able to completely remove the low-quality oxide without collapse. Selectra's extreme selectivity to silicon enables maximum active area of the silicon pillar. Another benefit of Selectra is that we can tune the process to etch just the residue or to remove all of the remaining hard mask, depending on customer preference. We can see that at the end of the process, the structures are still standing and ready for the next step in the process. In this example of a wet etch process, you can see that the low quality oxide is in fact removed, but then after the etch process is complete, the SDI structures collapse and become connected.
다음은 태양광입니다. 이번 동영상은 고급 셀 아키텍처에 대한 솔리온 XP 이온 주입기라는 것입니다. 디스플레이입니다.
We live in a visual world, where one picture is worth 1,000 words. Displays keep us informed, bring us joy, and connect us together wherever we are. Displays open windows to the world. Today, displays are bigger, brighter, thinner, more interactive and lower cost than ever before. Behind every major advance in display technology, you'll find the power of the AKT Display Group at Applied Materials. The magic is in the complex stack of layers, finely engineered and deposited by the amazing machines we make, enabling faster transistors with metal oxide backplane technology, providing a high-performance, low-cost path to achieving higher resolution, beyond HD to ultra-high definition, on ever larger displays offering an immersive viewing experience. Touchscreen technology brings glass to life, changing the way we work and play. This exciting experience is enabled by touch layers integrated directly on the display. Our systems can fabricate multi-layer stacks rapidly and accurately, helping to usher in a visual, interactive world. Today's mobile devices boast resolution and performance powered by low-temperature polysilicon transistors laid down by our state-of-the-art system. Our technologies are creating new display possibilities, such as brilliant, flexible, active matrix OLED displays. We're also scaling up the glass, enabling more displays to be made on bigger sizes to reduce cost, and using our electron beam test technology to ensure a perfect visual experience, any place, anytime. The displays of the future will be defined by resolution, touch, brilliance and scale. Our engineers and scientists are ready for incredible things. The new era of high-performance interactive displays is being made possible today by Applied Materials.
마지막으로 롤트롤 웹코팅입니다. 어플라이드 머티리얼즈 홍보를 끝마치겠습니다. 감사합니다.